Welcome to my Godot flip screen tutorial. This game that you see now is a game called Cybernoid, and it was written by Raphael Secco in the 1980s. And as you can see, you're flying your spaceship and navigating between screens, and every time you move to an edge, it flips to the next screen. Also on this screen you can see there's a HUD across the top with the score and lives, and that never changes. So in this tutorial we will be covering the first part, which is simply getting a map and letting us flip screens. In part 2 we will add the player controller, like the spaceship in this game, and in part 3 we will learn about adding a HUD. And in fact we will be using this game as a template. What you need to do is, the links provided in the video, is visit the website, find part 1 of the tutorial, and either clone it if you know how to use Git, or to simply use the download and the zip, and you will have the full project ready to run in Godot, and it will contain the first part. What is also shown is everything we're doing here in text form. Okay, and we will be going through all of this in the tutorial. If we just look at the end result, what we have is the map of Cybernoid, and if we use the cursor keys we can move through the map. You can see here I'm now going to go left, and we can go up and left and down. So here we have a Godot project which is empty, apart from I've included a couple of the folders from the download, but no code. What I've included is what we call a tile sheet. Yep. And this tile sheet contains every piece of graphic used to produce the map inside Cybernoid. So if we were creating a game from scratch, we would create a new scene and we would add a tile map. Okay. In our case, our graphics I know are 32 by 32, so we would go to the cell and change the default to 32, and then you can see the screen changes. Okay, and if you notice, this box here is the box that is our screen, and it's also, if you don't create your own camera, it is the default camera for your game, and that size is set in the project settings under general and display, and you can see I've already set mine to 512 by 320 because that is the size of the map that I'm going to produce. So if we were doing a game from scratch, the first thing we do is create a tile set, and in there we would just add the graphics. Yep. And then for each tile we would manually create a tile, like so. We then got the next one and add that. We will then add another one and another one, and we would keep going until we added all of the tiles that we wanted in the game. Then when we go back to the tile map, all of our tiles are there, and we can start creating a map, which, as you can imagine, it is quite tedious. So what we're going to do instead is have a preloaded tile map that I've already created, and it looks like this. So as you can see, it is the maps of, if I just remove the grid for now, as you can see, it is a tile map already made. Yeah. This tile map wasn't created by hand, it was created at this website called Specky Screenshots. It's got maps of lots and lots of games. If you look at the one called Cybernoid, as you can see, this contains maps of all of the levels of the game, and this in fact is the representation of this map. If you can see the resemblance. Yep. This is beyond the scope of this tutorial, but I took this bitmap of the map and passed it through a tool I wrote a long time ago called tiler. I'll put the links in the screen. So the tiler simply lets you supply a bitmap image, and it then produces as its output a tile sheet. Yep. And it does that simply by analysing the map and producing unique cells of whatever size you specify. Okay. I then use another tool I created called Godot tile map scene generator, which takes the output from this tool, which is, like I said, the tile sheet, but it also contains a CSV file containing the location of every where every one of these tiles should be, and it produces a tile map scene. So as you can see, I've got quite a lot of documentation, and in this case we can see we've got Mario, and yep. So and all the details are at this site as well. So if we load up the Cybernoid screen, then we get our map. Okay, there's no code, it's just a tile map. What I've also produced, if you notice, there's one called Cybernoid no BG, and that simply means I've produced a tile map and I didn't put any of the all black tiles in. So if you wanted your own custom backgrounds, this is how you would do it. And obviously you need to clean up these images with the black bits. Yeah, and just in case it was someone didn't like the Cybernoid, here is a map of Metroid, which you can use as well, but and obviously the no background version. But we will be sticking with Cybernoid. So in this map, all I've done is I've created an empty node 2D and put the tile in. The only reason for doing that is we might want to add more tile maps, which is how we add layers, for example foreground and background, which we'll do in the next scene. You might also want to use this map here to draw our non-tile map entities such as enemies. Yep. So if we run this scene now, as you can see, what you get is the top left corner of our map. And the reason for that is when you don't have a camera in Godot, it uses the default camera, which is in essence attached to the viewport of the game, which in our case it will display any scene, or in this case this tile map, starting at origin 0, 0. And like we said, the reason why we saw that amount was because we set this screen to be 512 by 320. Okay. What we want to do in effect is create a flipped version of this map. So just to help us, if we go to view menu and always show a grid, what you'll see is these yellow lines that handily mark out every one of our screens to make it easy. Yeah? And that was done because in these three dots here, under configure snap, I set the value to be 512 by 320. Okay, this is just a visual thing. Yeah. And your lines might be blue, but I made them yellow to be more visible, and you can see that through the editor settings. Yeah, somewhere in here is where you set the colors. As I said, when you run your game and you have no camera, you will get the default viewport. And you can see here, we just simply have our tile map. Yep. So it is just drawing whatever it finds in the tile map at location 0, 0 in the size that we set in the project settings. When you're creating your game, a scrolling game, what you will do is you might add a camera 2D within your player. Yeah, so pretend this tile map was your player, and then whenever your player moved, then the camera would move with it. So in order to create a flip screen, we create a camera, but we don't attach it to any one node. So in effect, it is just showing what is visible on the screen. So what we'll do is we will create an empty scene, and all we want to do is simply add a camera 2D. We don't want to do anything else. What we need to do is set it as current. So this means when our game starts, the camera will be the active camera rather than the default one. Now if you notice, the camera's normal origin is at the center. So if we change that to top left, then it will tie up with our tile map a lot easier. So 0, 0 is the top left. Okay. And if we save that, and what we'll do is we'll create a folder and we'll call it scenes. And we will call it, we will call it camera. Okay, actually one thing that we will do now for the camera is provide a simple means of changing its position. So the way you change the camera is simply alter its transform position. Yeah? And if you change that transform, then it will just make visible whatever scene that you're showing at that position. Yeah. So whatever we set this position to in the camera, because we are showing it at the top level of our game, it will show, in our case, the tile map at that same position. So to make it simple, or a bit easier, rather than modifying positions directly, we will add a script to the code. And we will add a function that will essentially let us modify the position. Okay, and this doesn't really do anything other than you pass in a location and a zoom level, and it will set the position of the camera to that position and also change the zoom. We won't be setting zoom, but it's there just in case we ever need it. Okay. We have our basic map here, and what we'll do is, in fact, we're going to create a controller for the map. So we'll add a new scene, we'll call it map, and inside of that, what we want to do is drop our map inside of it, so it is a scene instance of our map. Okay, so back to our tile map. As you mentioned, we have a node that contains our tile map, and we can add more maps and objects as we want. So what we'll do is we will create a script for our map, and with our tile map we have a blank screen, a blank script. To save some time, I've pre-created some constants. This will just simply allow us to navigate our map easier. So let me give you an overview of what's going to happen. In here we have all of our screens, and I've just numbered them 0 at the top left, going all the way down to the last cell. Okay. Now, this second row isn't screen number 6, and the reason being is that if you want to expand the map, then we might have to update all of these numbers every time we add more width to the map. So I've just presumed in this simple case that we're going to have up to 10 screens across, yeah, and any number down, yeah, but we'll always have 0 at the top left. Okay, so you can see row 2 starts at 10 and goes to 15, 20, and row 3 starts from 20 to 25, etc. So what we need to do to create our tile map is provide some basic means of managing these rooms. So that's what this does. So we have the map screen width of 10, and we know there are 10 screens across, and we know that each tile is 32 pixels squared, and from that we know that every screen is 16 by 10 tiles. Yeah. In other words, there are 16 tiles across and 10 down. Okay. And what we then do is we calculate the size of the screen, which in effect is going to give us the 512 by 320, and we do that by multiplying the number of cells by the cell size. Yeah. We have a start room of 3 because we want to start at this room here, and we have a constant called invalid room, which we'll be making use of later for when we do navigation to return whether a room is valid or not. So what we're going to do is create a 2D scene, and we'll call it game. We'll save it in our scenes folder called game. We will add a script which at the minute won't do anything. Okay. And what we want to do is we want to add an instance to our map, and we also want to add an instance to our camera. Okay. So as you can see, we have our tile map and we have our camera, and the camera, as you can see, is still locked firmly at position 0, 0. So if we run our game, we will find that the map is still showing here. Yep. So just an example, if I go to the camera node and I set its transform to say 300 by 300, as you can see it's moved to this location, and if we run our game, as you can see it's simply moved to reflect where the camera is. So hopefully, as you can see now, in order to produce a flip screen game, essentially all we need to do is modify that position of the camera, and we do that through calling this helper function set position. We're going to have some predefined variables. So the camera controller will point to our camera, and the map controller will point to our map. And we have a variable called current room, which points to the start room defined in our map here. What we now want to do is just add some code to handle the player input. Okay. So what I've done here is in the input event, we could do this in process or physics process if you wanted to, but I've just done it in the input event. And what we do is we check whether the user is pressed up, down, left or right, and we set a variable which we call direction to be one of our enumerators that we defined in the map. So if I show you the enumerator, whoops, I haven't created the enumerator. What I mean by an enumerator is simply we want to have a nice named version of a number. So we use an enumerator to give us up, down, left and right. Okay. As a temporary measure, just to get the game working, we will just hack some code in, and what we will do is, first of all, we will get the position of the camera as it stands now, which is 0, 0. We then want to write a match statement on direction. Yeah. And what we want to do, in effect, if I just give me 1 second and we will get there. Okay, so what we will do as a temporary measure is if we go up, then we will decrease the position, the current position, by whatever our screen size is. In this case, it is set at 512. When we go left and right, it will decrease or increase by the 320. Yep. If you remember, inside of our game, that was set here. And finally, we will just call controller our position. Okay. If we run the game, obviously there's no validation, but if you press right, then we go right. If you go down, we go down, etc. Yep. And if you go too far, obviously we're going to get blank screens. Yep. So that is, in essence, how we do flip screen. Yep. Change the position of the camera. So what we want to do first is create some functionality where we can manage our rooms a little bit better. What we have here is a simple dictionary called room data, and as the key it is the room number. Yep. And inside of each room is simply a single array, and it is an entity called exits. So what this means is each element in the array corresponds to up, down, left and right. So in room 0, -1, by the way, signifies you can't go there. So in room 0, we can go down to room 10 and right to room 1. So if we look at the screen, on room 0, we can go right to 1 and down to 10. Yeah, but we can't go left or up. I'm going to paste in a lot of code, but we'll go through it section by section. Okay, so what we want to do is provide a set of functions that will allow us to navigate the rooms, and also make sure that we can navigate them only if they are valid. So we also want to be able to do that by using room numbers such as these, but also by global positions, in other words pixels, because we might want to change rooms based on where the current player is. Okay, so what we've wrote is a set of helper functions that will, in this first one, will take any pixel coordinate and convert it into a room ID. So in other words, if we were at, say, global position 2000 by 2000, we can call this method and we will get a room number. And the maths involved in that is we first of all get a grid position of that room. What we mean by grid position is simply in each of these rooms, it's room 0, room 1, yeah, room 11, we want to get how many rooms across it is and how many down. So this room here would be 2 rooms across and 3 down. Okay. Now, because we know the size of each screen, which is 512 by 320, which is in our constant, we just multiply that grid of 2 by 2 and 3 by the room size, and that is what this code does here. Next, what we want to do is to say I have a specific location and I want to go right. So for example, I'm at 2000 by 2000. Can I move to the right or can I move down? So in this case, on this screen that I've got the mouse on, we can go left, we can go right, but we can't go up and down. So what we do with that is we first of all get the room ID at that location, and we do that by calling the method that we've just created. Yep. So we take the global position and get the room number. We then call a method which we haven't seen yet, which will essentially take that room number, a direction, and it will return what the room in that direction is, only if it's valid. Valid room and direction from room. So we pass in a room ID and a direction which is up, down, left or right. So the first thing we do is we have some guard functions to make sure that the room passed in is a valid room number. In other words, it has a key in our room dictionary. Okay. And the reason for this logic here with the OR statement is in Godot you cannot pass enums as parameters, you have to use integers, so we're just making sure that someone doesn't pass in a number 5 or 6 or 7. Yeah, if we could pass in enums then we wouldn't need this this check, yeah, but we can't, so this is what we use. And this line checks whether the room is in our dictionary. So what we do is we first of all get the array for that room. So in the example of room 22, we would return an array with these 4 values. If you remember, each one represents up, down, left and right. Yeah. And we have our direction passed in, which is up, down, left and right. So then we simply get the value from that array element and return it. So we will either return a number or -1. What we also want is a few extra functions to allow us to help the camera. So if you remember, the camera works in the top left coordinate. So room 1 is at 0, 0. Yeah? Room 1 is at 512 by 0, etc. So we have this function called get room top left global. So in other words, we have a room, let's say 23, yeah, and we want to return its global location in pixels. And we do that by, first of all, we make sure it's a valid room. Yeah. In other words, it exists in this dictionary. Yeah. If it doesn't, then we return that invalid room number that we said before, so we can trap it. What we then do is we convert that room into a global position. Okay. So in other words, yeah, any room we can get its global position. And just in case we need it, we have a function exactly the same as the previous one, but instead of passing in a room ID, we pass in a location. So in other words, if we are the player, which might be at any particular point, we call this function and we will get the top left corner of that screen. So in our example, if our player was in this point here where the mouse is, this function that we've just created would return this point here. Yep. So as you can see, with these two methods, we can set the map to anything we want. We'll not go through it in this video, but I've also created two functions called debug and test, which essentially, you can take your own time to look at it, tests all of these functions to make sure they are okay. So if I just give you a little example, if I run this scene, this is the output of my debug and unit test. And as you can see, well, everything is okay. Okay, so it's just a cheap way of doing unit tests without actually using a unit test framework. So, just to recap, we have a map which contains our tile map, and we have some code to help us navigate. Okay, and we also have a room manager. We have a camera which does nothing other than let us set its position, and we have our game. Okay, in that game we put our map and our camera, and we have some code on the input to handle directions. So all we need to do now is, because we've wrote the code for the camera and the map, what we will do is create a function called, in effect, manage direction, yeah, which is going to take in the direction that we've specified. Now this could be -1, yeah, or it could be a room number. So what we'll do is we'll flash out this function called manage room. Yeah. And what we do is, using the methods that we've just described, we find out from our current room what the room number is in the direction that we specified. So in other words, if we were at room 0 and we went right, then our direction is right. So we then pass that into our method to say, can you get me the valid room to the right? Now, if it's an invalid room, if you recall, it will return -1, which will bomb out. Otherwise, we assign our current room to this room. We mark the input as being handled because we don't want anything else to control the cursors, and then we call change room. Okay. So change room is, if you recall, is our global that contains our room. So when we start, it is 3. If we went right and it was of this method, would return 4 if we went right, and the current room would be 4. So then we just need to call change room. And change room is a pretty simple method that again calls our controller code to get the coordinates, the global coordinates of the top left of our current room, which, as we know, it is now set to room 4. So if we look at our screen, if we were in room 3, for example, and we called the method, get room top left global, we would return the position here. Yeah? When we move left, it would point to here. And then all we do is we call our camera and say, set the position. Okay. So if we now press play, in fact what we'll do, just to show you, if we go into project and settings, if we go to test width, and make it a multiple of our actual size, so 1024 by 640, then when we press play, we should get our map. Yeah. Now, if you notice, this isn't room 3. So the reason for that is in our ready function, we just need to simply say change room. Yep. And change room will update the camera to point to the current room, which by default is 3. So if we start, as you can see, we're in room 3. Now, if you press right, we can't move. Hopefully you can hear the keyboard. Yeah. But if you press left, we go left. We can't go left anymore, but we can go down, and we can go left. Yeah. You can go right, yeah, or left. Yeah. Now, in Cybernoid, I think, you can't go back to a room. So if we're in room 3 and we move to room 2, we can move down to 12, but we may not want to move back to room 3 because we might only want to allow the player forward progression. Yep. So at the minute, if you're in room 2, you can go to 3 and 12. So we can fix that easily because we have our room system. So if we go to our room data and we know room 3, yeah, as you can see here, we can only go room to left 2. And in room 2, we can go down to 12 and right to 3. So if we simply change that to -1 and run our game, yeah, we can go left now and we can go down, yeah, we can go back up, but we can't go right because we've blocked our screen. So you can see we now have a fairly simple and robust flip screen game. One last thing before we leave it, if we go into project settings, I'll go through a couple of settings that we really need to have for 2D games. So the first one is in rendering and 2D, and it's called GPU Pixel Snap, and this simply allows better alignment of, in effect, the textures on the screen, in particular on tile maps. If you don't have it on, then you could see blank lines in your tile map. This is in version 3.3. If you're using version earlier, typically 3.2.3, it is under quality. It is called Use Pixel Snap. Okay. The other thing that we want to change is we want to make sure that if the screen is resized, then we don't end up stretching our pixels. So under Display and Window, we will set the display mode to be viewport. Okay. And we will set the aspect ratio to be keep. The reason for viewport over 2D is a little complex, but at the Godot website, and I've put a link in the README documents, it explains it in great detail, but viewport is generally a better way than using 2D. And we use the keep on the aspect ratio to ensure that the aspect ratio is always the same, so it doesn't get stretched. So in other words, if we, for example, click on ignore and run our game, when we stretch our game, we end up with stretched graphics. So when we put keep, yep, we always ensure that no matter what happens, the aspect ratio always stays the same. As you can see, we're getting black bars, but our screen is the same size. Yep. And that concludes our tutorial. In the next one, we will add our player controller to let us fly around the screen. And for that, we will be enhancing the camera to allow us to check for collisions on the boundaries, essentially. Okay, and obviously in lesson 3, we want to somehow add a HUD to this map, and that is done through what's called viewports, and that will be in lesson 3. So if none of that made sense, then download the code and have a play yourself, or follow the guidance in this instructions, which is probably better than what we've just been talking about. Okay, thank you and goodbye.